Hey, what's going on, guys? We have a 2009 Saturn Aura. It's the same as like a Chevy Malibu. It's got the 2.4 Ecotech in there. Nothing too special. It was brought to me as a concern for no power steering. Customer's concern, obviously, the power steering did not work. Be a pretty easy problem to recognize. They start the vehicle up and it did not work. This particular vehicle utilizes electric power steering. It has an electric motor that's going to be bolted right to the side of the steering column, actually right under the dash, and uses that electric motor for the power assist. So there's no hydraulics in this power steering system. Electrical problem. Anyways, I'm not even really sure where she had it diagnosed or if she diagnosed it herself. Not 100%, but what we got, this was brought to me with this part saying, not that, hey, could you diagnose my problem, but could you throw in this component, which is a power steering control module, and it's actually the motor as well. You see the fins there to release heat from the control module. It's got the plug-ins there, but then it also has the actual motor bolted on. It's all one assembly. So in most cases, if you have a problem with the power steering, that's the component you're going to be replacing. And of course, it's not cheap. $600 for this. So I said, yeah, sure, you know, customer's always right. Right? Yeah. I said, yeah, sure, I'll throw it in there for you. But I told her I was going to check it out and I was going to make sure what was going on first before we spend all that money. Well, it was already spent, so hopefully she can return that, because I'll spill the beans. That wasn't the problem. Okay, so first things first, let's check out our codes. Trouble codes. I'm in the electric power steering control module that is in the vehicle. So we go to read codes here. There's our code C0545, steering wheel torque input sensor. All right. So for on these vehicles that use electric power steering, not only do they need a position of the wheel, position sensor, but it also needs a torque sensor. How hard are you turning that wheel one direction or the other? So let's look into the actual code definition itself. Get that printed off here. Alright, here's the definition about the code. The steering column shaft torque sensor is a 5-volt dual analog inverse signal device. What the heck does that mean? I'll show you in a moment. Which is used to sense steering direction and the amount of torque being applied to the steering column shaft when the steering wheel is turned. The valid voltage range of the sensor is 0.25 to 4.75. Okay, that's an important number to remember. But basically, this sensor has 4 outputs. 2 of them are for the position, and 2 of them are for the torque. And there actually are 2 different settings of the code. Ours is the 00, which is just for the input sensor. So let's look to see what it takes for that code to set. So right here, the torque sensor signal 1 and 2 voltages are less than 0.25 volts or greater than 4.75 volts. Okay, well, that seems pretty darn easy to recognize. So next thing, let's just check our scan tool and let's see what we can see as far as data. If it gives us a voltage level for this torque sensor, and we can look at the position sensor while we're in there as well. Okay, so torque signal 1, torque signal 2. We have 2.5 volts on 1 and what appears to be a slightly bouncing voltage on torque sensor signal 2. We do have some voltages on the steering position as well. So tell you what we're going to do. So I'm not going to graph those. Graph doesn't work that well. I want to move this wheel, see how those respond. So I'm moving the wheel right now. It does look like they're responding. Also, neither of them are outside of that range That one's real close. There you go. Torque signal sensor 2, you saw it there, drop out below 0.1. If we looked at our numbers that we were just talking about, that's our range. It's already, I think we've definitely got a problem. And I can tell you it wasn't actually going out of the range the entire time. The other thing that I noticed when I was reading was that both sensors, here it is. So ignition on, observe the scan to a torque sensor 1 and 2 parameters. With the steering wheel at rest, which it is, and I can even center this just to show you. So we don't have any force on that wheel. With the steering wheel at rest, both readings should be at 2.5 volts. While turning the wheel from side to side, they should stay in their range and change in opposite directions from each other. Okay, again, we're at 0.1 right now on that signal wire, and we're not moving it. Let's see if we can get it to react a little bit. It's really not. Now our signal 1, I was looking at the wrong signals. I was looking at the steering wheel position. We need to be looking up here. There we go. All right, so they're actually pretty close to where they need to be at the moment. And they are actually reacting. And this is where I was before too. I was looking at these voltages, and that concerns me right there, that I'm at rest. I'm not moving the steering wheel, and torque signal 1 is at 2.5, but torque signal 2 is at 0.9, which should be at 2.5. So what I wanted to do, my concern was, well, is this control module, where is this sensor? Is it built into the control module? So I pulled up a wiring diagram, and here is our power steering control module, which is that. Okay, so it does look like it contains a control module. You know, we're connected to the data network, we get power, get a ground there. That's really pretty much it. It's got ignition wake up, which looks like through the PSCM, and the actual motor itself. But over here, where it says steering column, steering shaft torque sensor. Okay, so this, according to this diagram, and I can confirm it's a separate component from this. That's important to know, because this is where our problem is, particularly on the torque sensor portion. Okay, so let's look, what are the things that we want to check on this? We get a 5-volt reference, which is shared by both sensors. We get a low reference, or a computer supplied ground, that is shared by both sensors. And then we have 2 outputs from each of the sensors. So what I really want to focus on is the output from this torque sensor, particularly torque signal 2, which is on my purple wire. So what I did was, we've got our little buddy, the U-scope, under here, and we are, if I can get you up under here, we're actually back probed on torque signal 1. And the reason I chose to do 1 first, if that's the light blue wire, okay, again on our diagram, light blue is torque signal 1. I wanted to show you the good first, okay? So, I'm gonna put the scope right up here so you can see me turn the wheel at the same time. Now, do you see how that's responding? A nice, smooth analog signal. So when it was telling us the description of the sensor, a dual inverse analog signal, it means that each output puts out an analog signal inverse to one another. So when this goes up, if we were to look at the other torque signal, it should go down. Really all it's doing is telling the control module how much torque we are applying to that steering wheel and in which direction. All right, so again, this is good. This is what you want to see. Nice, clean signal. So now what I'm going to do this one-handed, is, sorry if you can't see it, I'll show you once I have it back probed. I'm going to go on the wire for torque signal 2. Now I am at the control module. That's where I'm back probed. So now we're back probed into torque signal 2, basically right there, this purple wire that comes from the sensor. So now we're gonna watch this sensor. Now right off the bat, again, we're not at 2.5. Matches what we see on our scan tool, and even it's bouncing around. But this really drives it home here. Now watch as I just barely touch this wheel. I mean, barely. Now look at the reaction to that, all over the place. Now if I move the wheel, we actually get something that looks similar to our other signal, but look at the dropouts. If I start moving this, those dropouts in that sensor. I mean, and this is really where it is. And this little movement, that the computer can't handle it. It doesn't know what's going on. We did not see that in our known good. And again, plus the fact that our resting voltage is a volt when it should be 2.5. So the only other things that I need to check are my 5-volt reference and my low reference to this sensor, because that's the only thing it needs to function. I can tell you though, the steering wheel position sensor is working right, so those are good, and I already did check them. I'm not going to do it on video, but you can trust me that my 5-volt reference and my ground are good to go there. We are getting a bad signal, so this is what needs to be replaced to fix this problem. All right, so that's a wrap.